Welcome to The Explainer. I am absolutely thrilled you're joining me today because we are going to explore something we all possess, yet, we rarely know how to properly navigate it. Think of the human body for a second. It is definitely not some flat two-dimensional drawing. It's a wildly complex three-dimensional landscape just absolutely filled with layers of tissues, interlocking bones, and winding vessels. If you were an explorer dropped into an unknown territory, you wouldn't survive very long without a highly precise map and a compass, right? Well, the exact same goes for medicine and anatomical science. Without a standardized way to navigate this biological landscape, things can get incredibly confusing very quickly. So today, we are going to solve what we call the Mapmaker's dilemma. We'll discover the elegant, really foolproof system anatomists use to safely navigate the human body, specifically focusing on how we map out our limb. Okay, let's dive right into this. To really understand why we absolutely need a specialized language, I want you to imagine a scenario. Let's say you're looking at a patient's medical file, or perhaps a doctor is giving directions for an upcoming operation, and they write that there is a scar or a lesion, quote, above the wrist. Think about that phrase for a moment. Above the wrist. Where exactly is that? If you ask 3 different people, you're probably going to get 3 completely different answers.
When you say above, do you mean it's up on the forearm, maybe 2 or 3 inches away from the hand? Or do you mean it's located right at the base of the hand itself? And what about the orientation? Are we talking about the palm side of the arm or the back side? So, as we can quickly see, there is an inherent danger in using colloquial, everyday terms like above or below in a clinical setting. In our daily lives, sure, those words work just fine. But in an operating room or a diagnostic lab, this kind of ambiguity could literally lead to treating the wrong area entirely. A surgeon needs to know the exact millimeter they are targeting. Everyday language simply doesn't possess the rigorous precision required for human anatomy. To solve this massive problem, anatomists established the ultimate solution, the anatomical position. You can basically think of this as the true north of our standard body map. By definition, it describes a body standing upright, with the feet at shoulder width and parallel, toes pointing forward. The upper limbs are held out just slightly to each side, and this is absolutely crucial, the palms of the hands are facing forward. Why is this so foundational? Because we use this exact orientation as our reference point no matter what position the actual patient is in. Whether a patient is lying down face up or face down on an operating table, clinicians still use directional terms as if the patient were standing in this standard anatomical position. It completely, 100% eliminates the guesswork. Now, what's really interesting about this is how this standard anatomical language acts as an infallible compass. Once we have our map oriented to the anatomical position, we can use these directional terms, which always operate in clear binary pairs, to eliminate any confusion. Superior pairs with inferior for vertical orientation, anterior pairs with posterior for front and back. And if we draw an imaginary line right down the center of the body, anything medial is moving toward that midline, while lateral means moving away from it. By pairing these terms, an anatomist can pinpoint literally any organ or structure in the torso or head with incredible accuracy. However, the map encounters a pretty major glitch when we get to the appendages, because arms and legs move totally independently of the torso. Terms like superior and inferior completely break down when applied to the limbs. Think about it. If you're standing with your arms at your sides, your shoulder is superior to your wrist. But if you throw your hand high into the air to ask a question, suddenly your wrist is physically higher up. It's superior to your shoulder. If a doctor notes a fracture is superior to the elbow, does that mean it's on the upper arm? Or did the patient have their arms raised, making it on the forearm? Yeah, we need an entirely different set of rules for the limbs. And this brings us to the core focus of our explainer today. For the limbs, we throw superior and inferior right out the window and replace them with 2 vital terms, proximal and distal. Notice how these terms relate to distance. Proximal describes a position in a limb that is nearer to the trunk of the body or nearer to the limb-specific point of attachment. Distal is the exact opposite. It describes a position that is farther from the trunk or point of attachment. Instead of relying on gravity or which way the limb happens to be pointing, this system uses the main trunk of the body as a permanent, unmoving anchor point. No matter if you are doing handstand, swinging a baseball bat, or lying completely flat, your shoulder and hip joints never change their position relative to the rest of your arm or leg.
Let's trace this path and see how it builds a precise map of the upper limb. Actually, I encourage you to look at your own arm as we chart this out using the proper terms. We start at the attachment point, the shoulder. Moving outward, the area we commonly call the upper arm is anatomically strictly referred to as the brachium. Continuing down, the forearm, which consists of the radius and ulna bones, well, that's called the antebrachium. Finally, we reach the wrist, known as the carpus. By giving each specific segment a completely unique Latin or Greek-derived name, we remove all the vagueness of everyday words. If a clinician says brachium, they mean the upper arm, period. And this brilliantly illustrates exactly how we use our new directional compass on this anatomical map. If we compare the upper arm to the forearm, we say the brachium is proximal to the antebrachium. Why? Because the brachium is physically closer to the shoulder joint, that unmoving point of attachment, than the antebrachium is. It totally doesn't matter if your arm is hanging loosely by your side or reaching way up to grab a book off a high shelf. The brachium will always be proximal to the antebrachium. The physical distance along the bone structure never changes, giving medical professionals a foolproof way to describe locations. We can apply the exact same logic to the lower limb, which of course has its own specific regional terms. Our permanent anchor point here is the hip joint. Moving outward, we find the thigh region, which is dominated by the massive femur bone. Next is the kneecap, or patella. Below that is a term that actually surprises a lot of people, the crus. You see, in strict anatomical terminology, the word leg, or crus, is reserved exclusively for the area between the knee and the ankle, where the tibia and fibula bones reside. You would actually never refer to the thigh as the leg in a clinical setting. Finally, we reach the ankle, composed of the tarsal bones. So let's test our compass out on the lower limb. If we are comparing the crus, that lower leg region, to the thigh region of the femur, we confirm the relationship by stating the crus is distal to the femur. This makes perfect sense, right? Because the crus is situated farther away from the hip's attachment point than the mighty femur bone is. Once again, whether the patient is kicking a soccer ball or just sitting comfortably with their knees bent, the crus remains structurally distal to the femur. It is a brilliant, completely foolproof system of navigation. So the crucial point here is simple. The purpose of this language is not to confuse, but rather to increase precision and reduce medical errors. Look, it can be incredibly intimidating to look at a medical textbook filled with ancient Greek and Latin roots, terms like brachium, anterior, proximal, and distal. I get it. It feels like learning a dead language. But I really want you to remember that memorizing these terms isn't just some academic exercise meant to torture medical students. Because these classical languages are no longer evolving in everyday conversation, their meanings are locked in stone forever. And that guarantees that clinicians across different hospitals, or even across different decades, are literally on the exact same page. This precision saves lives. Which leaves us with a pretty profound thought to end on today. Consider the long and honestly often dark history of medicine before these terms became globally recognized. How many disastrous medical errors were made before this universal map and compass were finally standardized? How many times did a vague direction like cut below the elbow lead to tragic consequences simply because the patient happened to be lying in an unexpected position? Today, thanks to the foundational concept of the anatomical position and these clever directional terms like proximal and distal, we can navigate the wondrous complexity of the human body with absolute certainty. I really hope this explainer gave you a newfound appreciation for the rigid, lifesaver precision of anatomical terminology. Thank you so much for joining me, and keep exploring.